Hi everyone, and welcome to another episode of Debugging Maths. So in this video, I will introduce you to the elementary probability that will likely show up in your test and your exams. So I recommend you guys take notes and pay rapt attention to every single thing I'll say in this video. Otherwise, the whole elementary probability will look like rocket science, and in real time, it's actually very simple. So now that I've gotten that out of the way, I'm Nathaniel, and let's get started. So there are four very important key terms in elementary probability that you should know. We made a video on binomial probability and we defined some really important terms there as well. So I'll put the link in the description of this video. So a random experiment, there are those type of experiments that once you carry them out, you cannot beforehand or you cannot predetermine their outcomes, or you cannot beforehand know exactly what outcome will play out. Sounds kind of vague, right? Let me use an illustration to explain it further. An experiment, we know an experiment from previous video from a binomial probability distribution. So I explained there that experiments are trials. So for example, if I flip a coin, I pick something, or if I ask you to pick, if I ask you to flip a coin, to throw a die, all that, those are experiments, because probability is very unpredictable and you don't know exactly what will happen. If you did know exactly what will happen, then we're not doing probability anymore. So don't mind my jug. So this is a jug, for example. So let's assume now that inside this jug there's no water inside now, and let's say I have this black ball inside and this other balls inside. So I have one black ball. Let me add another black ball to it. So let's assume I ask you to close your eyes now and I shuffle this the balls inside. So that means you don't actually know the position, and I say pick. That process of you picking is called an experiment. Now the probability of you picking any of these balls, I don't know, you might swing your hand this way, you might swing your hand that way. It's completely random, you get? So that's why it's a random experiment. Another way to think about it is, when you hear random experiment, think of it of I don't know experiment, or you cannot predetermine the outcome of the experiment. Like I said, it's very simple, and make sure you're taking notes of exactly what I'm talking about, and make sure you keep them too, because when you start doing econometrics, you will need to remember some of all these terms like that. Sample space, very easy as well. Sample space is just the total population or the total set of outcomes in a random experiment. So we already know what random experiments are. Let's assume a coin, a tail will show up or head, but I don't know exactly, so that's why it's random. So now in this random experiment, the sample space is just the total, or the complete set, the whole population of all the likely outcomes that will occur. So let me give you another illustration so we can picture certain things. The sample space in this cube now will be the population. So I can get a 1, I can get a 2, like I can get a 2 side, I can get 6, and of course in a set braces. So this is the total population of every single thing that can happen. There's no way you can get a 7. So a 7 is not it's not part of the sample space. It's not an element in the sample space. So now what is the probability of getting a 1? So the probability of getting 1, like one side, one of the face, which is 1, will be the probability, the element I will care about, which is just one side divided by the sample space. That is the total number of possibilities, total number of the total outcomes, the total likely outcomes, which is 1, 2, 3, 4, 5, 6 side. So that's 1/6. So but what is the probability of the probability? This is how you write it, or you can use this, the probability, anyone that rocks your boat, the probability of getting a 2, that's the face 2. So that is this. So if I throw the die now, I want this side to come up. So the probability of getting that side is what is the favorable, that what am I interested in? That's this 2 That's 1 out of the total number of sample space divided by the total number of possible outcomes, which is 6. What is a sample point and what's an event? So a sample point is just one element in a sample space. The phase 3, which is this phase here, is a sample point, a single element in the sample space. But what about an event? So an event or events are possible outcomes in a random experiment. You know what random experiments are. An event, let me repeat that. So an event is a possible outcome in a random experiment or a possible outcome in the sample space. But how is that different from a sample point? A sample point is one element in a sample space, and now I am saying that an event is a possible outcome in this sample space. But what is the difference? So give it a try. Pause the video and find out what's the difference between an event and sample point. A sample point is just one element. So 1 is a sample point, 3, 6 is a sample point. But an event is the moment you assign probability to that element or elements, it becomes an event. So the probability that the element or the sample point 1 will occur becomes an event, right? The probability that 2 will show up becomes an event. The probability that the element 2, the 2 side will show up is an event. Now the probability, same thing, that the side 6, the phase 6 will show up is also an event. The moment you assign probability to the sample point, it becomes an event. So make sure you take notes because they will ask you in the test or in the exams. You can say an event is a subset of the whole sample space. So let me make that clearer. If I say what is the probability of getting a side that is even, that's probability of getting 2 or the probability of getting 4 or the probability of getting 6. So these are the even numbers, right? These are the even numbers, and you can see that this is a subset of the sample space. What's the probability of getting 1 out of, so this is the probability of getting 1 out of the whole sample space. You can see that it's a subset. Probability of getting the phase 2 is a subset. So this one you really need to pay attention to it because even in econometrics it will pop up one way or the other. So this kind of probability, you can also call it restricted probability or limited probability. So it's a type of probability that you cannot go somewhere except something has occurred already. So if I say, so what's the probability of a 2 occurring given that the probability of 6 has occurred? That means what they are trying to say is that what is the probability of these 2 happening when maybe I throw the die 2 times. So what is the probability that I will get a 2 in the second, like the phase 2 will show up when in the first experiment or in the first toss I got a 6. So let me take that again. So what is the probability that the side 5 will occur given that the probability of 6 has occurred? You get? Meaning that it's very limiting. That means this one is never going to happen until this one has occurred. That's what I am concerned with. It's like you can rephrase it. Another way to think about it is, what is the probability that these 2 will occur given only that this one has occurred? Or what is the probability that we are interested in this, we can only be interested in this when this probability has happened? So we need to find the probability of this first before going to find the probability of this one. Very, very simple, right? So let me give you another illustration so it makes more sense. So what's the probability that when you throw this die the second time you would get a 6 given that you have gotten a 1 in this first throw? So you can see that we are conditioned. So meaning that if we throw this first one, this first die, and we get a 2, then it's not counted. All we care about is the probability of this first one becoming a 1, so that the probability of the second the second experiment, the second toss or the second throw of this die to C will be a 6. So how do we write this conditional statement? So we can write it like this, that the probability of us getting a 6 in the second toss, that's of us getting a 6 in this second side, given that's the notation there, given that, or given only that in the first throw, I'm using this like first S to represent first throw, that we got a 1 like this. So this is how you write it. You can write it anyhow you want, as long as you can put this is the first, this is what we want, given that we have gotten this before. So this is the second toss, given that the first toss was a 1 side that showed up. So now you pause the video and try answering this question. Try writing a conditional statement for this question. What is the probability of us getting a 2, given that we have gotten a 4 already? Alright, now so let's write it down together. So the probability, this is how it will look like, of getting a 2, given only that we have already gotten a 4. So that means we have 2 experiments. This is the second one, and this is the first one. So what we are saying here is, what is the probability of us getting a 2 in the second toss, given that the first time already we've gotten a 4? So you can see that it's very limiting. If you get in the first toss, if you get a 5, it's scrapped. If you get a 6, it's scrapped. If you get 1, it's scrapped. You can only get, the moment you get a 4 in the first toss, then you can proceed. Then the probability of us getting a 2 will now be the next one. You can see that it is conditioned, it is tied. So we'll discuss more about this in other later videos. This is just part 1. In other subsequent episodes, I will discuss about this in full. I will solve more questions about it. So these are the key terms you should know before even solving elementary probability questions. Alright, so that's it for me. Keep debugging that maths, and I'll see you guys in part B.